This video is about the mechanism of migraine. What is going on inside your head? Hello, my name is Craig Blackwell. I'm an ophthalmologist from Santa Cruz, California. Migraine is a remarkably interesting subject in medicine. Beside the obnoxious headache, if you know what you're looking at, it is a unique chance to see the inner workings of the brain on display. In the first video, we described the migraine experience, what you see and feel with the migraine. In the second video, we discussed the clinical aspects. Remember, this is for your information, as it does not replace consultation with your doctor. Let's start off by recognizing that migraine is not defined by the headache. It is best to think of migraine as a group of various neurologic symptoms that occur in episodes and share a common cause. A headache is usually involved, but not always, and migraine appears to be inherited. Speaking of various neurologic symptoms, this is the full International Headache Society list of different types of migraines. There are too many to discuss them all, so we will limit this discussion to the three most common types. These are different ways of combining two things, headache and aura. Aura is a particular visual display or sensory defect that comes just before the headache, if there is one. The three types are 1. Common migraine, which is the headache alone with no aura. 2. Classic migraine, which is aura followed by headache. And 3. The aura alone, visual or otherwise, but with no following headache. The IHS terms are different, but I will stick with these historic names because they are familiar and easy to remember. The features that identify a headache as being a migraine are: the headache is one-sided, usually throbbing, with nausea, possibly vomiting. There is sensitivity to light and sound. Pain is made worse by physical activity, and it lasts from 4 to 72 hours. The aura is a sensory disturbance that occurs with the migraine episodes. It can involve vision, sensation, or movement. 30% of people with migraine have the aura. Here is the beginning of the typical visual display. It starts with a little missing area, like in the picture on the left, which grows over a few minutes into a crescent of zigzag flashing lights, like on the right. Some describe it as like a kaleidoscope, others use the term scintillations. At full development, it may cover half the field of vision. Within the crescent, there is an area of vision that goes missing, that is called the scotoma. Note that it involves the same half of vision in both eyes. After 15 to 30 minutes, sometimes longer, the flickering lights gradually fade away and vision returns. Rarely there can be a blackout of vision, but that must be distinguished from other worrisome causes like stroke. Some people have an aura that is not visual. Instead, it involves sensations of numbness and tingling that march down the arm, or numbness of the hand or around the mouth. In the accompanying videos, we will explore the clinical aspects of migraine, but in this one, we are going to concentrate on the mechanism. To understand migraine, we will need to get acquainted with the brain. In this side view, you can see the brain is divided into lobes. For example, the frontal lobe, parietal lobe, occipital lobe, etc. Within each lobe, there are areas which are specialized for a particular function. For example, in the back of the frontal lobe is the part that controls movement. In the front of the parietal lobe is the part that serves sensation. In the far back of the brain is the occipital lobe, which processes vision. The brain is also divided into right and left halves. You may already know that the right side of the brain controls the left side of the body. Here is how that right and left division works with vision. You can see in the diagram how an object in the left half of vision projects to the right side of the retina in each eye. The optic nerves carry that information to the visual part of the brain, the occipital cortex, maintaining the right and left division of information. To be precise, the right and left division occurs at a crossover point where the two optic nerves come together, called the chiasm. That is important clinically. If vision is affected in one eye only, then we are looking for a problem in front of the chiasm. If vision from both eyes is involved, like a migraine or stroke, then we know the problem is behind the chiasm somewhere in the brain, on the opposite side of the vision defect. To take a look inside, here is a slice through the middle of the brain. The outer layer is called the cortex. It contains the bodies of the nerve cells that make up the brain. It is also called the gray matter. Each nerve cell sends out a long process called an axon that connects to and communicates with other nerve cells. The axons make up the central white matter. Taking a piece and getting a closer look, this magnified view of the surface of the brain. For orientation, I have included the skull bone on the top. Inside the skull there are protective layers called meninges, which also contain blood vessels and nerves. It is important to note that these are the pain-sensitive structures in the brain. The substance of the brain itself does not feel pain. Pain signals coming from the meninges are carried by branches of the trigeminal nerve, labeled TGN. These signals travel through the brainstem and then are sent to the pain-sensing parts of the brain. It is important to include this because the trigeminal nerve mediates the pain in migraine, which we will talk about in a minute. Up to a decade ago, the explanation of migraine was essentially vascular. It went like this. A trigger event, commonly stress, caused an artery to spasm, which reduced blood flow to a particular part of the brain. If the vessel supplied the vision part of the brain, that was the cause of the aura and missing vision. After a period of time, the spasm would relax and the artery would dilate, restoring blood flow. But the artery would dilate beyond its normal size, causing the artery wall to be stretched, and that would create the pain. This theory sounded good, but ended up being wrong. Improved research tools revealed a different process, pointing to a neuronal rather than vascular cause. Accurate methods of measuring blood flow in the brain show that blood flow during a migraine attack did not follow the predicted pattern. Yes, with the aura there was a decreased blood flow, but the spread of the aura overlapped boundaries of arterial blood supply in the brain. And vasodilation and increased blood flow did not correlate with the headache. To the contrary, blood flow remains reduced or normal through the beginning of the headache phase. So the old model is gone. Considering the current model, let us realize that it is a work in process and is still got major unanswered questions. In general, the current model has 3 steps. There is still a trigger event of some kind. Then, in people who have an aura, the aura symptoms are caused by an electrical disturbance that spreads over the surface of the brain, called a cortical spreading depression. 3. Pain. This may be the toughest one. There are several theories we will cover in a minute. Remember the cortex as the outer layer of the brain. Since it is composed of nerve cells, you can picture it as constantly abuzz with electrical activity. But sometimes the normal electrical activity can be disturbed. That is the cortical spreading depression we mentioned before. Picture it like the passage of a thunderstorm. A wave of increased electrical activity starts out in a particular spot, usually in the occipital cortex. It spreads gradually forward over the surface of the brain at about 2 to 3 millimeters per minute. After the wave passes, electrical activity in the area behind is significantly depressed. The speed and spread of the electrical excitation exactly matches the progression of the shimmering part of the visual aura. The following area of depressed activity is responsible for the missing area called the scotoma. In this diagram, the cortical spreading depression is starting in the visual cortex where it causes the visual aura, but it could also involve the sensory part of the brain, causing some people to experience numbness and tingling, or it could involve the motor part. As the aura resolves, that is when the headache pain usually starts, if there is one. The next big question is, where does the pain come from? Broadly speaking, there are 2 likely sites of origin. One is the cortex and meninges, and the other is the brainstem. Regarding the cortex, there is more than one theory, but the general idea is as follows. Cortical spreading depression causes inflammation in the meninges, and it directly stimulates the trigeminal nerve. Either one of those things, or both, could cause the pain signals that are carried to the trigeminal nerve and the brain. In the brainstem theory, almost all the sensory information going to the brain must pass through the brain stem on its way to the cortex. Some researchers suspect activation of nerve groups in this critical area could send pain signals directly to the brain, and activated nerve groups could send signals that cause the cortical spreading depression. But there are a number of details still to be filled in here. There is a third cortical pathway that is also important. Migraine people have been found to have abnormal sensory processing of pain signals. Some researchers think abnormal pain perception may end up being a key factor in migraine pain. Now, this is a good time to talk about serotonin, an important neurotransmitter in the brain. As far back as the early 1960s, researchers noted a relation between blood levels of serotonin and migraine. One of the actions of serotonin is as a vasoconstrictor. Under the old theory of migraine, it was thought that this action could be used to reverse the vasodilation and pain of migraine. Researchers set out to find a medication based on serotonin, but that would only act on the cerebral blood vessels, avoiding systemic side effects. In 1984, they succeeded, making sumatriptan, later sold as Imitrex. There is no doubt that triptans have been very successful in treating the pain of migraine. However, since the likely cause of pain has changed from vascular to neurogenic, that raised a new question. If they are not working on blood vessels, how do they work? Back at the drawing board, new research found that there are receptors for serotonin throughout the brainstem and cortex. Regarding migraine, the triptans act on serotonin receptors in several places. In the meninges, they block release of inflammatory chemicals. In the brainstem, they inhibit pain impulses, and they may act on central pain perception. This is only half the story. Serotonin is also important in regulating sleep and mood and processing of pain information. Regarding mood, one of the main causes of depression is reduced levels of serotonin. Successful treatments of depression have been medications that work specifically to raise these levels. People who have migraine have also been found to have low serotonin levels, specifically decreased baseline levels between migraine attacks, but elevated at the onset and during a migraine. With that in common, it turns out that some of the medications used to treat depression, for example Elavil, can also help prevent migraine. More broadly, one part of current theory of migraines goes like this. In migraine people, the low baseline levels of serotonin makes the brain more sensitive to adding any extra amounts of serotonin. Then, an event like stress causes sudden release of stored serotonin. The extra sensitive brain cells overreact, and on comes the migraine. This is a major area of current research. The other recent development regarding treatment is the discovery of a chemical called CGRP. What it stands for isn't important, but it has been found to have a significant role. Stimulating the trigeminal nerve causes a release of CGRP in the meninges, where it causes inflammation. Administering CGRP intravenously to migraine people recreates their headaches. Treatment with medications that block the action of CGRP are effective at reducing the headache. Some researchers think this is the key step in migraine headache. So if triptans work, why bother with a new medication? The value of CGRP blockers is that they avoid the vascular side effects of triptans. Early trials suggest they are well tolerated and effective, so this is likely to be the next big thing in migraine treatment. As you can see, there is still a lot to learn about this interesting disorder. In the accompanying videos, we look at what you experience with migraine and migraine as a medical disorder.